Okay, so let's do this question. Okay, determine the y parameters for the network. So here this is the given network, and here you have a capacitor 1/2 Faraday. Here you have another capacitor 1/2 Faraday. You have 1 Henry and 1 Henry inductors, and the question is to find the y parameters. Also check whether the network is reciprocal or symmetry in nature. Okay, so since this is y parameters, okay, and only for y parameters, I am going to apply node analysis or Kirchhoff's current law in this circuit. Okay, that is the most easiest thing when it comes to y parameters, because basically when you look at the equation, y parameters means we are expressing I1 and I2 in terms of V1 and V2. So therefore, since these are all current equations, the best approach would be to apply it in terms of the node analysis, so that it will be much more easier. Okay, so first let me apply the Laplace or the transform portion of the circuit. Let me apply draw the transform network. So in that case, you see this here the value of the capacitor is 1/2 Faraday. So 1/CS. So it will become 1/2S, or this is nothing but 2/S. Okay, so this capacitor is 2/S, and this is Ls, and here L is equal to 1, so which means this is nothing but S. Okay, all right. So let's draw a circuit. So here the circuit is we draw a capacitor, and the impedance of this capacitor is 2/S. Then we have an inductor, and the impedance of the inductor is Ls, or simply S. And the capacitor over here, and this is also 1/2 Faraday, which means the impedance is also same, 2/S. And here you have the inductor. Here it is 1 Henry, which is Ls. So L is equal to 1. So you have 1 into S, 1S, or simply S. Okay, so this is the circuit. Right. Now next is here you can see that V1, I1, V2 and I2 are not marked, so we should mark it. Okay, so which means let me mark it over here. So which means this is plus minus. So this is V1 plus minus. This is V2, and this is the current into the port 1 is called as I1, and current into port 2 is called as I2. Okay, irrespective of which parameters they are asking, the direction of I1 and I2 always remains the same, which is going into the network, and also the position of the voltage at port 1 and port 2 is also same. Okay, so now what I'm going to do is I'm going to apply y parameter. So like I said before, whichever parameter they are asking, first you write the equation, so you'll have a clear-cut idea of what you're trying to achieve. So here we know that the equation for y parameters is that I1 is equal to y11 v1 plus y12 v2, right? And what about the equation for I2? I2 is equal to y21 v1 plus y22 v2. Okay, you see, this is what you need to understand. See, there are different ways of doing different problems, but the thing is, some methods are actually very easy, some methods are actually very difficult. You see, by applying some methods, you'll be able to do this problem in maybe in half a page, or at least in 1 page. You can at least be able to complete the problem by applying a method. And if you solve that same problem using another method, maybe that method might be very difficult. So in that case, you will take 2 or 3 pages in order to solve that answer. You see, so you need to choose the right method for the right circuit, right? So since they are here, the reason why I am applying Kirchhoff's current law over here is because basically we are using a current equation. That is why node analysis is much better than mesh analysis. Of course, you can solve this problem using mesh analysis, but then it will be very difficult for you, right? It will be very difficult because then there will be a lot of steps, a lot of processes, and then only you can express in terms of that, in terms of the current equation. But here, node analysis means basically we are writing the current equation, so it will become much more easier. So here, what I'm going to do is I'm going to apply node analysis, which means I need to mark these 2 nodes and express them in terms of the equation, and that's it. That's all you need to do. Then you can simply rearrange the equation to have this kind of a format, in these 2 formats. So first see, if you look over here, this is V2, right? The voltage at this point is V2. The voltage at this point is V1. So if this is V2, then this is also V2 because there is no obstacle in this path. You see, this entire thing is a single connection. This entire line is a single connection. So which means if this is V2, then this is also V2. So therefore you can mark this point as V2 itself. Okay. You need to understand that why this is V2 is because there is no capacitor or inductor or resistor or anything in between over here. If there was, then you have to give another name to this point. Okay. So since this is V2 and since this is shorted, therefore this is also V2. Now what about here? Here you have V1, right? We already have V1, but there's a capacitor here, which means the potential over here is different. So you have to give another name for this node, and already we have used the name V1 and V2. So let this be V3. Okay, that's it. This be V3. So now what I'm going to do, I'm simply going to write the node equations, and then finally I try to rearrange them so that I can express I1 in terms of V1 and V2 only, and express I2 in terms of V1 and V2 only. Okay, so let's do this. So here what we are going to do is, first I'll write the equation for V3. Okay, so for according to the equation of V3, we have the equation of V3 is minus I1, because the current over here is already given, it's called as I1. And why it is minus? Because it's an incoming current, right? When you're going to write when I'm going to write the node analysis, all the outgoing current is positive and all the incoming currents are negative. So this is incoming, so that's why it's minus I1, plus the current through this branch is V3 minus 0 by S or V3 by S, plus, and the current through this branch is V3 minus V2 by 2 by S is equal to 0. Okay, this is the current equation. So in that case, what is the equation for I1? The equation for I1 is, see, since I1 is going from here to here, which means this is a higher potential, this is a lower potential, so therefore I1 is equal to V1 minus V3 by 2 by S. Okay, so this is the equation for I1. Okay, so what I'm just simply writing the equation, then I have to think how to rearrange them so that I can make it look like this. Okay, that's what I'm doing. So I found the equation for this, I found the equation for this. Now next I'm going to write the equation for V2. So what is the equation for V2? It is V2 minus V3, V2 minus V3 by 2 by S, okay, plus V2 minus 0 by S or V2 by S minus I2 is equal to 0. So that's the other equation I got. Okay, so like that I found these two equations. So now if you can see here, see in this equation and this equation, one of the interesting fact is that in both these equations, V3 is, and I don't want V3, I need to express in terms of V1 and V2, both of them in I1. So here I need to see only I1, V1 and V3, but here there's I1, but there's V2, but there's V3 also. Instead of V1 we have V3 also, which means I need to remove V3, or I need to replace V3 with some other equation. Same place over here also. See, here I need to have only I2, V1 and V2, but here there's V2 and there's I2, but there's V3. Instead of V1 there's V3, which means I need to write and express this, remove V3 by expressing some equation for V3. Okay, that's what I'm going to think. So this is what I'm going to do. So how to do this is that what I'm going to do is I need to express V3 in terms of V1 and V2, right? That's the common logic, which means I will apply this equation over here. Okay, I will apply this equation over here. So therefore the equation will become V3 minus V1 by 2 by S plus V3 by S plus V3 minus V2 by 2 by S is equal to 0. Okay, see, of course, when you are doing this problem, maybe you might find a method which is much more easy than the one I'm showing you. If you're able to do that, that's well and good. Okay, so that's what you need to think and you need to see which method is much more easier. So anyway, I'm going to do this method. Okay, I'm going to apply this method. So here what I'm going to do is I'm going to multiply the entire equation with 2 by S. So in that case I will get V3 minus V1 plus this into 2 by s will give you V3 into 2 by s square plus, and here 2 by s will cancel, so you have V3 minus V2 is equal to 0. Or in other words, we have V3 into 1 plus 2 by s square 1 plus 2 by s square plus 1. Okay, and then I'm going to bring V1 and V2 over to the other side, so this will become equal to V1 plus V2. Okay, or this is also equal to V3 into, so this is s square, so you will have 2s square plus 2 by s square. Okay, this is equal to V1 plus V2, or in other words I see that V3 is equal to V1 into s square by 2s square plus 2 plus V2 into s square by 2s square plus 2. So there I found the equation for V3 in terms of V1 V2. So simply substitute that over here and over here and you got your answer. So first I'll substitute that over here. So here I1 is equal to, according to this, I1 is equal to, let me see, V1 into s by 2, V1 into s by 2 minus V3 into s by 2, minus V3 into s by 2, but V3 is this one, so I'll substitute that over here. So I'll get V1 into s by 2 minus, and I get over here is V1 into s square by 2s square plus 2 plus V2 into, you have s square by 2s square plus 2 into s by 2, okay, or in other words you will have V1 into s by 2 minus V1 into s cube. So we have over here as s cube by 2 into this. Okay, so it becomes 2 into 2s square plus 2, 2 into 2s square plus 2. Okay, I hope this is correct. Minus, again minus, because this minus comes over here, right? So this we have, again this becomes s cube by 2 into 2s square plus 2. Okay, so I need to combine these two and then I have found the answer. So V1 into, I got V1 into s by 2 minus s cube by, maybe I just rearrange this, I'll make this, I'll take 2 common out, so it becomes 4 into s square plus 1, right? Yes, this is minus 4 into s square plus 1 minus V2 into, and this is s cube by 4 into s square plus 1. Okay, that's it. So now what I'm going to do is I'm going to take the LCM and multiply both of them. So this will become, here here you have 2s into s square plus 1 over here, right? Because here already there's 2 over here, so which means if the LCM here, we know that the LCM is 4 into s square plus 1, right? Make common sense, we can see the LCM is 4 into s square plus 1, so which means here you need to multiply it with 2 into s square plus 1, so it becomes 2s into s square plus 1, and over here there's nothing to multiply, so it's minus s cube, I believe. Okay, minus, or you can say plus V2 into minus s cube by 4 into s square plus 1. Okay, or this is can also be written as V1 into, so this is 2s cube plus 2s minus s cube by 4 into s square plus 1 plus V2 into minus s cube by 4 into s square plus 1. Okay, so you got this. So that means you get over here as 2s cube minus s cube is s cube, and you can take s also common out, right? Or it become s cube plus 2s. That's it, right? So you just s cube plus 2s by 4 into s square plus 1. If you take s common, you'll get s plus 2 and it won't get cancelled. So there's no use of taking s common. So this is your answer, okay? Plus v2 into minus s cube by 4 into s square plus 1, okay? This is I1. So we know that I1 is equal to v1 into y11 plus v2 into y22, which means this is, by comparing these two equations, we can say that this is y11 and this is y12. Sorry, y12. This is y12. This is y11 and this is y12. Now I need to, same way I need to apply it in terms of, I'm going to apply it over here in terms of I2. We know that from here we can say that I2 is equal to v2 into s by 2. I2 is equal to v2 into s by 2 minus v3 into s by 2 minus v3 into s by 2 plus v2 into 1 by s plus v2 into 1 by s. Okay, maybe I can join these two and make it a common. So you will get over here as v2 into s by 2 plus 1 by s minus v3 into s by 2. Okay, and this is equal to, now if you look over here, we have already, that's what we did before, right? We already did the value, expressed it in terms of v3, but not only that, this is also v3 into s by 2, v3 into s by 2. See, same thing over here also, v3 into s by 2, here also v3 into s by 2. So which means I can cut short my calculation, right? Which means that this is, I expressed it already over here, I did the calculation over here, and so I will get this answer. This is my value. So substitute this value over here, so it will save a lot of time. So I will have v2 into s by 2 plus 1 by s. Okay, then you have minus, same thing, just copy the same equation over here, so it will save a lot of time, minus v1 into s cube by here the denominator you can write like this, right? That is 4 into s square plus 1, 4 into s square plus 1. Okay, all right, minus v2 into s cube by 4 into s square plus 1, s cube by 4 into s square plus 1. Okay, so that's it. See, so now I need to write this in terms of the equation. So here I can say v1 into minus s cube by 4 into s square plus 1 plus, and regarding about v2, you need to combine all the values. So you will have v2 into, here you have s by 2 plus 1 by s minus s cube by 4 into s square plus 1. Okay, so this is actually v1 into minus s cube by 4 into s square plus 1. Okay, 4 into s square plus 1, and over here we have, let me see, over here we have plus v2 into, what is the LCM? That will be the most difficult thing. No, let me see, here you have 4 into s square plus 1, here you have 2, which is already over here, but there's no s over here, which means the LCM is 4 into s into s square plus 1, right? So that is the LCM symbol. So that's the LCM. So in that case, the numerator over here is already, there's a 2 over here, so which means the remaining value will multiply 2s into s square plus 1, right? That is the numerator over here, plus, and here there's already s, so which means the remaining value is 4 into s square plus 1, okay? And over here the only thing missing is s, so which means you need to multiply the numerator with s, so you'll get minus s raised to 4. That's it, okay? This is the value you got. So therefore you have v1 into minus s cube by 4 into s square plus 1 plus v2 into, and here you have, I'm going to open everything up, so you will have over here 2s cube, okay, you have 2s cube plus 2s plus 4s square plus 4, okay? There's already an s over here, I believe, right? Let me see over here. There is, yeah, there's already one more s over here, so into s over here, okay? Into s, because this s also should also be taken into account. So this will become 2 raised to 4 plus 2s square, right? Yes, 2 raised to 4 plus 2s square plus 4s square plus 4 minus, and here you have s raised to 4 by 4s into s square plus 1, okay? So this is what you get, or in other words you get v1 into minus s cube by 4 into s square plus 1 plus, now be very careful over here, let's see, this and this will cancel, so you will have 2s raised to 4 minus s raised to 4 is s raised to 4, and here 2s square plus 4s square is 6x over, so you get plus 6s square plus 4 by, and here you got 4s into s square plus 1. So this is your answer. Or in other words, this is nothing but I2 is equal to y21 v1 plus y22 v2. So this is y21, this is y22. By comparing these two equations, we can say that, okay, by comparing these two equations, we can say that this is y21 and this is y22. Or in other words, we can say that, okay, by writing this equation, we can come by comparing this equation, we can say that, or just write like that, you know, by comparing the equations with y parameter equations, we get that is, now I can write in matrix form, that is the best way, that is y11 y12 y21 y22, okay, is equal to, and what is the value of y11? This is the value, that is s cube plus 2s, s cube plus 2s by 4 into s square plus 1, 4 into s plus 1. The equation for y12 is this one, minus s cube by 4 into s square plus 1, 4 into s square plus 1. And for the y21, the equation is minus s cube by 4 into s square plus 1. And the equation of y22 is s raised to 4 plus 6s square plus 4 by 4s into s square plus 1, okay? So this is your answer. So when you see this answer, you can see that to check if the network, since, let me see, if it's any one of the, see, what about reciprocal, y12 is equal to y21 y21, and for symmetry the equation is y11 is equal to y22. Okay, so let's see here. Yeah, here y12 is equal to y21, but y11 is not equal to y22, which means the network is reciprocal, but it is not symmetrical. All right, so let's write that. Since y12 is equal to y21, which is equal to, for both of them the value is minus s cube by 4 into s square plus 1. Okay, since y12, then the network is reciprocal. Okay, network is reciprocal. Okay, and here as you can see, y11 is not equal to y22, so therefore since y11 is not equal to y22, then the since y11, then the network is not symmetric. Okay, so the network is not symmetric. So this is the answer. Okay, so this is how we do the problem. So only for y parameter, just remember, only for y parameter is always better you apply the node analysis instead of mesh analysis. For the remaining parameters, that is for Kirchhoff's for Z parameter, for transmission parameter, for hybrid parameter and all that, you need to apply, it's better you apply mesh analysis. Okay, you can apply any method you want, but I would prefer mesh analysis. Okay.